Let's see, reliable versus reasonable. Yeah, those are two different things. And here, is you referring to the confidence level, Tammy? All right, so we are going to take a look at StatKey, and we're going to look at Bootstrap confidence interval for a mean, and we're going to take a look at the restaurant tip data. And to get you there more easily, let's put a link in the chat and in the YouTube description. So here I have a sample, original sample of n equals 157 tips at a restaurant. The average tip was about $3.85. And so here I can see a graph of it. It's a little bit skewed right, so I'm gonna give a really big tip out here. And this isn't percent tip, this is the amount of money, right? So these are dollar amounts in here. And the data is located here, $10, $7, $5.01, and so on. So what I want to do with this right here is I want to come up with an estimate for average tips in this restaurant in general, okay? Not just based on this. I think this is from one day at the restaurant. So to do that, what we're going to do is we're going to generate a whole bunch of samples based on this one. And this is the idea of bootstrapping. So basically the computer has 157 cards in a deck. Each card has a number on it right there. And what we're going to do is we're going to resample from this. So if we do 1, it grabs the cards, it shuffles the deck, and it looks at the cards one at a time and writes down every number it gets. So some of these, like the $4.02, could be pulled more than once. So I get this new sample based on the original one. I just have one of them. It has a slightly higher mean. But what I want to do is generate thousands of them. I want to make what's called a sampling distribution. So I could do 10 more samples of size 157. I could do 100 more samples of size 157. I want to do thousands of them. And generally, to create an interval estimate based on a simulation like this, we usually want to do more than 6,000 samples. This runs in your web browser on your computer, so the speed at which it generates 1,000 is going to vary from computer to computer. I have an old laptop at home, which this sets the fan spinning pretty heavy. I'm going to go up to 8,000-ish. So I have 8,111. So I have more than 6,000. So if you want to try this, you do the same thing. Now, this is not population data. This is sample data. Population in this case would be all tips at this restaurant in its existence and into the future, based on one sample. So what I'm trying to do is I have a point estimate. My point estimate is I can say, well, the average tip at this restaurant is about $3.85. Okay, now I want to get the margin of error. To get the margin of error, we make at least 6,000 samples, and then we choose this two-tail button here. And what that does is says, okay, we're going to find the middle 95% of data by taking a look at where's the bottom 2.5%, make a mark, gather the next 95% of data, so that's now 97.5% of data, make a mark. And it's giving me those 2 marks right here. So an average of $3.49 is the low end of my estimate. An average of $4.24 is the upper end of my estimate. So these are those lower and upper values. So when you do a confidence interval in StatKey based on some data, what StatKey is going to give you after you generate thousands and you click two-tail, it's going to say, okay, here's 95% in the middle. Here's your middle. Now notice the middle here is a little different than the sample middle, and you could go with either one here. I'm going to go with the one they state down here. And then they give me the lower and upper bound. What they don't give me is the margin of error. So I'll show you how to get the margin of error out of this. So the next thing I would do is in my notes, I would write down these 3 numbers right there. So I'm going to take a screenshot of those to do that. Usually I have a piece of paper in front of me and I just jot down those 3 numbers like they're on a number line. So what I'm trying to do is find what is the average tip at this restaurant. I have a sample of n equals 157 tips. Sorry, 157. 157 tips. And the average of those x bar was a little bit different than this number at the bottom here. It was 3849. And that's a dollar amount there. When I ran those thousands of different samples, so this is like 8,000 samples, each of size 157, those 8,000 samples of size 157 had an average of 3.851. It's a little bit different than that. So I'm going to call this my, my estimate here. I'm going to say that's my new x bar right there. This would be my lower value. This would be my upper value. And remember, the upper value is always the mean plus the margin of error. And the lower one is always the mean minus the margin of error. So I think the easiest way to get the margin of error out of this right here is to find the total width here, how far is it all the way across, and then cut it in half. So to get the margin of error here, I think the best way to do it in StatKey is to take the upper number, subtract the lower number, right? Find out how wide this interval is, and then cut that in half. So my upper is 4.236. My lower is 3.487. And I'm going to subtract those and divide by 2. So I'm going to whip out a calculator, do that. And some calculators you need parentheses, so cautious with your calculator, 4.236 minus 3.487. 2. And you guys have seen me do this before. I'm sure I just used the Google search engine as a calculator, type in my calculation, it whips out a calculator. So I took the upper value minus the lower, divided by 2. So Google says my margin of error is about 0.3745. Now, since each of these numbers, the 3851, my middle, and my upper and lower, those are all dollars, this would be a dollar amount also. And so I might round those, but sometimes I ask you to keep a certain number of decimal places. So
why couldn't you just subtract the upper from the...
Yes, you can, but the reason I do the upper and the lower is because we're doing a computer simulation here, and there's a great deal of variability going on. In the simulations, the distance from the mean to the upper is always going to be a little bit different than the mean to the lower, which will also be a little bit different than half of the spread. So to average out that variability, I just go upper minus lower. But you are correct. In theory, we should just be able to take the upper number and subtract the mean. So let's just double check that we do that if we get the same value. So if instead I take the upper and we don't subtract, divide by 2, so the mean was what, 3.851 on this particular one, I get 0.385. So this side of the margin is 0.385, which is a little bit bigger than the average spread. So this one's going to have to be a little bit lower to compensate. So if we double check that, that one's 3.487. So on the other side, it's 0.364. So that's one thing about these simulations. They're almost never symmetric. So then the question is, which one do we use for the margin of error? Is it 0.364, is it 0.385, or is it 0.3745? And my advice is to use this method here in StatKey. That kind of averages out the slight unsymmetry of this graph. It's mostly symmetric, but not perfectly symmetric. So we're always going to see those differences there. So let's write this down as a useful formula. The margin of error can be found by taking the upper estimate minus the lower estimate and divided by 2. So that's generally the way we'll use StatKey to get the margin of error. StatKey is always going to give us the mean, the number in the middle. Other useful formulas. The lower is always going to be the middle, in this case x bar, minus whatever we have for margin of error. And the upper is always going to be x bar plus the margin of error. So these are 3 useful formulas for jumping back and forth between the mean and the margin of error, or the lower and the upper to the margin of error. Similar formula to this one right here. If we didn't have the mean and the margin of error, and we just had the lower and the upper, taking the difference and dividing by 2 gives you the margin of error. If you wanted the mean, you would just add them up and divide by 2. So the upper minus the lower, or plus the lower, excuse me, divided by 2, that'll be the middle. So again, anatomy of point estimates and margins of error. The point estimate is something like x bar in the middle, and then we have these lower and upper estimates related to it. Now, ideally, they're going to be symmetric. That is, the distance from here to here is going to be the same as the distance from there to there. But in the simulations, that almost never happens perfectly. They'll just be close. This distance is the margin of error, ideally. So here's a picture of the relationship between these 4 numbers and then some equations that go along with that. And at that point, we are unfortunately out of time for fun with inferential statistics today. So we have covered so far some stuff from most of the stuff in section 3.1. There's a couple things I got to go back and go over on sampling distributions. 3.2 on the idea of a confidence interval. 3.3, which is just more about confidence intervals. And we haven't gotten to 3.4 yet. We'll talk about that next class. And review here, and there's a few things I skipped over on purpose that I'll come back to later. And 3.4 just looks at other confidence levels besides 95%, that 2 standard deviation rule.